Hello, boys and girls. Welcome to your first flipped lesson performed by yours truly, your teacher. This is going to be lesson 2-1, and we are going to start by labeling our first clean page in our notebook. Today I'm going to show you how to do prime factorization. So you can label your notebook, fresh page, prime factorization. Up at the top I'm going to put a page number, and this will depend on what page number you are on in my book. I'm just going to show you. The last page I did was page 10. So in my notebook, my table of contents, I'm going to go ahead and write. I'm going to skip a line because this is a new section. This is 2-1. I'm going to put prime factorization here. And then I'm going to put the page number, page 11. Okay. If you need to stop the video, pause it right now to make sure you have that filled out. Please do so and resume when you're ready. I'm going to continue on. Okay, so prime factorization, page 11. For this example, we're going to call it example A. And you're going to be finding the prime factors of 12. So there's a couple ways that you can do this. The first way we're going to talk about is using a factor tree. Factor tree. So when you use a factor tree and you're going to try and find the prime factors of 12, I'm going to start by writing 12. And the tree, it's like the tree branches that are coming out from the 12. And I want to say, what are two factors of 12? So, for example, 3 times 4 would be 12. 3 is prime. So I'm going to look at my composite number, which is not prime. And composite numbers, by definition, are able to be broken down into prime numbers. The factors of 4, 2 times 2. So this is my factor tree. You continue factoring until all numbers are prime. So go ahead and write that down in your notebook. Continue factoring until all numbers are prime. So 2 is prime, 2 is prime, 3 is prime, so I am done factoring 12. Now, when you write this out, you need to make sure to write the prime factors in sequential order. So the prime factors of 12 are 2, 2, and 3. And I put circles around them to kind of keep myself organized so that I know once I've used them not to use it again. The order of the prime factors is important. They do need to be in sequential order, so let's go ahead and write ourselves another important note. Write the prime factors in sequential or sequence order. Meaning that you start with the lowest and then you go up to the highest factor. Now this is not the only way you could do a factor tree. Let's take the same number, 12. I could choose to factor it using different numbers. I could use 2 because 2 times 6 is 12. 2 is prime. 6 is composite, so I'm going to break down and factor 6. 6 is 2 and 3. Now you'll notice here, no matter which way I do it, I get the same primes. 2 and 2, 2 and 2, 3 and 3. And as I write them down, again, I circle them. You should be writing them in sequential order, but they're going to be the same. Continuing on, there is another way of finding the factors of a number. So we're going to call this example B. Example B is another method. And for this one, we're going to find the factors of 60. We're going to find the factors of 60. Remember, if at any time you're not keeping up with the video, feel free to pause it so that you can catch up and restart it when you're ready. This method that I'm going to be showing you is called the long division notation. Long division notation method. So because we're going to find the factors of 60, we're going to use a division bracket, but instead of starting up at the top and working down with this long division notation method, we're going to start at the bottom and work up. So I'm going to start with the 60, and I'm going to draw a division bracket, a very long division bracket. You need a lot of space for these, with the 60 being over at the far right. On this side here, this is where I get to put the factors. One thing you need to know about this method is that you can only use prime factors. So one of the prime factors of 60 is 2. 2 goes into 60 30 times. So I can write that above, just like I do a regular division problem. And then I'm going to draw another bracket with a step on it. And I want to ask myself, what prime factor can be divided into 30? 2 can be divided into 30. 2 divided into 30 would go 15 times. And then I want to draw another bracket with a step. Another prime factor of 15 is 5. 5 goes into 15 3 times. 3 is prime, so I need to stop here. I can't go any further. I don't draw another bracket. Once you have your final prime here, you stop. Now we need to put these in order, in sequential order. So 60 is equal to 2 times 2 times the 3 that I already circled times 5 in sequential order. So these are the prime factors of 60. This concludes our first flipped instruction lesson for our class. Please make sure you have completed these notes, bring them with you to class tomorrow, and be prepared to dive a little bit deeper in how to choose whether to use the long division notation or the factor tree. Thanks for watching.